All right, so today we're looking at the systems of the human body, which is much less complicated than our evolution unit. If you look at your notes guide, you see each system has a picture, and the picture, and then it has two boxes, one for the function and one for how the system works. So there's going to be one slide for the function and one slide for how the system works for each of the body systems. So on this PowerPoint, I'll just put each slide up. I'm not going to talk too much about each one, but I'll leave it up so you can copy this information down. If the video goes too fast, remember you have access to the PowerPoint as itself, as well as the video on Canvas. So let's dive right in to the respiratory system. The respiratory system is how we breathe. So here we're on the slide. This is its function. It basically allows us to take in oxygen and we expel carbon dioxide. So oxygen comes in and carbon dioxide comes out. We breathe through our lungs. And you can see down here, I have the anatomy that's involved with each system. All right, moving on to how the respiratory system works. The respiratory system works, as you can see in this little GIF here. We breathe in through both our nasal cavity and our oral cavity, meaning we breathe in through our nose and our mouth. And this brings oxygen into our lungs. The diaphragm, which the diaphragm is actually down here, it helps support the lungs and it helps move them. So when you take a really big deep breath and you breathe all the way down into your diaphragm, that's much different than the short shallow breaths that you're just taking into the top of your lungs. So a short shallow breath goes into the top of your lungs and a big deep breath is actually using your diaphragm. Big deep breath is going to give you more oxygen, and which then travels to your blood and your muscles and everything there. So that's how the respiratory system works. Moving on to the circulatory system, because these two are very connected. The circulatory system, how this is its function, and what it does is it moves oxygen, nutrients, carbon dioxide, hormones, and of course our blood around the body. It contains the heart, of course the blood vessels, arteries, veins. So this is basically the highways and the little roads of our body. All right, how it works is, and you can see the little dots here on the image, the blood moves through the heart and then is pumped by the heart through the rest of the body. It communicates with the nervous system to control heart rate and blood pressure. So for instance, if somebody jumps out and scares you, your heart rate is going to go up, which is going to make your blood pressure go up. And this is to move adrenaline for your fight or flight reflex through your body quicker. It also allows you to react quicker, like to, basically run away. So other things can happen. Let's say you're doing yoga and you become really relaxed, your heart rate is going to slow down. The blood starts moving more slowly through your body and allows you to relax. So your circulatory system, it does work with the nervous system. It also works with the respiratory system because that's where it gets the oxygen. So you can see there's blood vessels right here in your lungs. All right, moving right along. This is your nervous system. Your nervous system controls movement and senses. So these first three systems, the respiratory, the circulatory, and the nervous system, these three all work together. Technically, all the systems in your body work together. These three work very closely. But this controls movement and senses. So you have your central nervous system, which is this picture here. It goes from your brain down your spinal cord, and then all of these nerves come out from here, down your arms, down your legs, and so forth. The peripheral nervous system connects every nerve in the body to the central nervous system. So that's its function. How the nervous system works. It controls voluntary action, which is conscious movement, like putting down your phones right now and writing your notes instead. That's a conscious movement. It also involves involuntary actions. Involuntary actions are like breathing or your heart beating. You cannot control involuntary actions. You can control your breathing, but you're not going to have your body stop breathing. If you do, hold your breath for long enough, eventually you pass out, and then your body starts breathing again because it's an involuntary action. Other involuntary actions are, sending signals through your body, some digestion, and things like that. So, sorry, that's my dog. The nervous system, again, does control voluntary action as well, such as movement and feeling. So, for instance, if you touch the hot stove, your nervous system senses that it's hot and you pull your hand away. All right, your immune system. Your immune system is the body's defense against bacteria, viruses, and other pathogens. So this includes your lymph nodes. So if you've ever been really sick and you feel those lumps right there under your chin next to your throat, you can also feel them in your armpits. And sometimes they get swollen when you're sick, and that's because they're working. This also includes your bone marrow, which makes new blood, B cells and T cells in your blood, and leukocytes, which are white blood cells. If you've ever seen the Magic School Bus where they go inside the human body, the white blood cells protect against infection. So your immune system is something that you're born with, a little bit of an immune system that you get from your mom during pregnancy and right there after birth. And then we develop an immune system throughout our lives. So you're probably sick a lot more as a young child. And this is your body developing its immune system. As you get older into young adulthood and adulthood, you'll find that you still get sick because we're always introduced to new pathogens, but you start to get sick less often. And that's because these leukocytes and B cells and T cells, so I'm going to highlight this in yellow here because this is important. These actually remember our pathogens that we came across. And so if you come across the same cold virus again, your body's going to remember it and have a better time fighting it than it did originally. This is why it's so dangerous for babies to be out early on in life, is they don't have this immune system built up yet. So how it works, there's two different defense systems. So there's non-specific or innate immunity. This is just going to be your general immunity. Your white blood cells, your skin is a big one in this because your skin prevents a lot of this from getting into your body. And then you have your specific acquired immunity. The acquired immunity is what you get throughout your lifetime that I was just talking about, how your body over your lifetime protects against specific things. So the non-specific, like it sounds, repels all microorganisms equally. So again, this is your skin and your white blood cells. Whereas your specific immune responses are tailored to a particular type of invaders. So both systems work together. These immune systems also help eliminate abnormal cells. So sometimes our body can eliminate cells that could develop into cancer. We eliminate those before they ever do. Now, your immune system is aided by things like vaccinations. So what vaccinations are is they're a dead version of deadly diseases that are injected into our body. So the dead versions trigger a specific immune response. So once you have that dead version of, let's say, measles, your body then develops a specific immune response against measles. So if you ever came across it in the actual environment, you would be immune to it. This allows for these diseases to basically be non-existent. Recently, people have been thinking that it is okay not to vaccinate their children. There is no science behind this. The person who said that they should not vaccinate children has since has his medical license revoked, and he has admitted what he published was false. So we know that vaccinations are very, very good. And some people cannot be vaccinated. So there's some disorders that people can be born with that make it impossible for them to be vaccinated. Other people have their immune system compromised. For instance, somebody that's going through chemotherapy does not have much of an immune system. So if everyone around them has vaccinations, then we are stopping the spread of deadly diseases. Whereas once we leave people unvaccinated, now these diseases are coming back and spreading to people who could be vaccinated or could not be vaccinated at all. So vaccinations are a very important part of modern medicine and a way that we can make our specific immune system even stronger. All right, so the reproductive system. So obviously there is two versions of the reproductive system in male and female, and this is what allows humans to reproduce. So the male reproductive system includes a penis and testes, and they produce sperm. Sperm are produced throughout a male's entire life. The female reproductive system is the vagina, uterus, and ovaries, and these produce eggs. The ovaries specifically produce eggs. Eggs are really only produced during development of the female, and very few eggs are produced throughout her lifetime. How the reproductive system works is during fertilization, which we all know how that happens. The sperm cell fuses with an egg cell, which creates a zygote, which turns into a blastocyte, which turns into an embryo. At the blastocyte stage, the embryo implants into the uterus of the female, which is right here, and this is what forms a new baby. So the blastocyte implants in the side of the uterus and then grows throughout development in the next 9 months. All right, the digestive system. This is the function of the digestive system. It contains a series of connected organs going from our mouth through our esophagus down to our stomach, intestines, and so on and so forth. There are a lot of organs that are involved in our digestive system. It is most often our favorite system because it deals with food, and we all like to eat. Now, what it's doing with this food is it's breaking it down into its cellular level. It's absorbing the nutrients, or those macromolecules, so carbohydrates, proteins, lipids, and nucleic acids from our food. It also removes the waste. So if you're eating a lot of junk food, it's breaking down and removing waste, but not absorbing a lot of nutrients. Or if you're eating a lot of nutritious food, it's absorbing that, and then you still have some waste products regardless. There's some things in all foods that we cannot digest. You can see in our little image here how the food goes through the body. So I'll let this run a couple times through. So food going from our mouth, down the esophagus, into the stomach and liver, pancreas, intestines, large intestines, and then into poop. Now, the liver is removing a lot of the toxins from the food, whereas the stomach is removing a lot of the nutrients. So you have mechanical digestion, which is up here and in the esophagus and mouth. And that mechanical digestion you saw was breaking down the food from a solid object into smaller pieces. The stomach is where it actually breaks it down. So you can see it changed color there. That's chemical digestion, and that's when we start using things like our stomach acids and other bodily fluids. All right, and our final and last slide. And so I'm going to leave this up for a little bit. But again, this PowerPoint is on Canvas. You can also find this image online. In the very last page of your notes, you want to label the parts of the brain, as well as I would suggest color coding them. Your test on this subject has several questions on each system, but I would say the most questions on the, not most of the questions on the test, but a lot of questions on the test involve the parts of the brain. So you want to understand each lobe and what it does. So I'm going to spend a little bit more time on this one. The frontal lobe is for problem solving, and it's in the front here. So if this is your head, this is going to be the front of so your face is over here. You have problem solving, emotional traits, or reasoning, judgment, speaking, and voluntary motor activity. You might have heard the story of the guy back in the 1800s. He was a very well-mannered, easygoing guy, and he was working building railroads, and at one point he had a railroad spike, which is about a foot-long metal spike, go in through his eye and up through the top of his head. So it went straight here through his frontal lobe. So a big spike went right through there. Now when this happened, he survived, and everything was fine, and he went back to work until he started acting differently. He became much more aggressive, starting bar fights. He started taking a lot of risks, like gambling a lot and things like that. So what was affected was his reasoning, emotional traits, his speaking, his speech changed. He actually changed the pattern of his speech. So eventually, because of his this injury, he eventually ended up dying earlier than he probably would have, but he did survive for quite a while. And this was one of the first case studies or cases where people started to think, well, wait a second, maybe the brain isn't just like one big lump that it does everything. Maybe there's different parts of the brain that do different things. So we know the frontal lobe is that. The frontal lobe also takes until about age 25 to develop. So that is why a lot of times we look back at decisions we made, let's say in middle school, and you look back and you just start cringing. You're like, oh, why did I do that? Right? It's because your frontal lobe had a different decision-making process back in middle school than it does now. And it's going to have a different decision-making process when you're 18, when you're 20, and when you're 25. And because it's still developing. All right, so moving on back through the head, next one's a parietal lobe. So if you put your hands on the top of your head, on either side of your head, you're touching your parietal lobes. This is where you know your right from your left. It also has to do with sensation, so touching things. It's where your body develops its reading skills, and body orientation, so like knowing which way is up and down. So if you get really dizzy, this is involved with your parietal lobe. All right, moving to the very back of your head, your occipital lobe. This deals with vision and color perception. This is why if you've ever fallen and hit in the back of your head, you might see stars, right? And major head injuries that happen to the occipital lobe can cause people to go blind, right? We'll go to the cerebellum and the brainstem at the end, but the temporal lobe, which is over here right behind your ears, coincidentally has to do with hearing. It's also your memory, behavior, and understanding language. So this is your language center of the brain, and it develops pretty early in life, which is why people who learn different languages earlier in life tend to do better. So people who are raised learning or knowing 2 or 3 different languages, it's easier to pick them up early in life because of when this temporal lobe develops. Although you can still learn them later in life because that lobe is there. All right, the cerebellum. This is going to be a small section at the bottom of your brain next to the brainstem. So this controls balance, coordination, and fine muscle control. So fine muscle control is different than normal muscle control. Normal muscle control would be like walking down the street. Fine muscle control is being able to write something or tie your shoes. That's going to be fine muscle control. Brainstem. Okay, this is going to control your breathing, your body temperature, digestion, alertness, swallowing. So this is going to be a lot of functions that have to do with your peripheral nervous system and as they come up into your brain. So your brain stem's right here. That's the part of the brain here. I'm going to go ahead and erase all this stuff on the slide so you can see it more clearly. And so on your paper there, you want to give a gist or a summary of what each one does. Each section of the brain does, as well as segment them off and color them in. And you can segment just general lines here. They don't have to be perfect, but so that you can at least see what they do. So that's our body system slide. I suggest rewatching the video or going back and going through the PowerPoint to see what each section of the brain does, as well as what each part of the body does. Your body systems test is going to be in just a couple class periods. It's not a lot of information. It's pretty easy to memorize. After your notes are checked off, so after you have shown them to the person teaching the class and they have checked them off in the grade book, you can cut them up and put them on note cards. That's what I would suggest doing. That way you can go through the notes that way. Just keep the note cards in case anything happens, and I can double check your notes because I will check them as note cards as well. But remember, study how you want to study, and if you need anything, make sure you are going back to this video on Canvas. All right, have a great day. Thank you.